Now I'd like to talk about variance and variability. We've talked about measures of central tendency, right? And again, measures of central tendency, that is a measure of what the center of our data set looks like. But we're also interested in the spread around the center, right? So if we just did a couple of quick, just kind of histogram approximations here, right? We would see that this, and this may all have the same mean, right? But this one's very tightly around the mean. This one's very spread among the mean. This is just kind of a mess around the mean. So measures of variance can kind of give us some of that information. Let's look at a kind of a numerical, more practical example. So if I can create two data sets, right? So I have two samples of ticket prices. So for an event ticket price. And so maybe I'm interested in, is Ticketmaster or StubHub do better pricing? This is, a solid question we would need to ask. And for a particular event, let's say that I pull 5 tickets from Ticketmaster and I pull 5 tickets from StubHub, and I find they have the exact same mean, right? That the ticket price mean is $27. Okay, well that's a measure of central tendency, that mean, but it really, okay, so now I can't, so on the one hand I could say, well, could go either way. They're equal in some ways because the mean is the same. It's worth taking a look at the spread around the mean. So let's say company A, which maybe it's Ticketmaster or whoever, the first ticket was 24, 30, 31, 23, and 27. So ultimately the mean here is 27, and our spread seems to go from like 23 to 31, right? And then I look at B, maybe StubHub or somebody else, and there it's 15, 27, 7, 39, and 47. Well, that's a much different spread, right? This one's actually pretty tight around 27 by comparison. This is pretty far spread out around 27. So while with company B, with StubHub here, I might get away with being really cheap, but I might also have to pay a lot of money. There's a wide spread. I don't know that I'm going to be near the mean. Whereas with company A, with Ticketmaster here, and of course I don't know anything about either of these ticket prices, so I'm just making this up. What I find is that, it may not be 27 exactly, but it'll be something very close to that. That's why we study variance. That's what we're interested about. And look, almost all research in psychology is about variance. We're always very interested in why things and how things vary from the mean, right? So I'm just thinking this from a high level point of view. If I want to look at training or the effectiveness of training, right? I might just say, well, the average level of knowledge, right? The mean level of knowledge is what's useful to me. But what I'm interested in is, why do some people know more and why do some people know less? What is about that variance from the mean that is so interesting? We are trying to explain the variance of the mean. So when we're doing correlation, or we're doing regression, we're doing predictive analysis, what we're really trying to do is explain variance away from the mean. So variance is a very important concept that we need to have in psychology, even beyond just this idea of a spread of answers on a histogram. It's really at the core of what it is we're trying to do, is understanding what that variance is made up of. And so we're always trying to find explanatory variance. So if I'm looking at the variability, if you will, because variance is a term of art, if I'm looking at the variability within a data set, I have a couple of different options. One is I can just look at the range, right? And the range of scores is actually a single number, but we usually think of it in terms of the min and then the max, right? So with company A, my minimum was 23 and the maximum was 31. For company B, the minimum was 7 and the max was 47. So here we would say the range was equal to 40. Here we would say the range is equal to whatever 31 minus 23 is. I do not math well, so I use my calculator. The range is equal to 8. Now, technically speaking, when we talk about the range, we're talking about this single number that describes the difference between the maximum and the minimum. In reality, when people report a range, they usually just report the minimum and the maximum, right? So from company A, ticket prices ranged from 23 to 31, and company B, the ticket prices range from 7 to 47. But technically the range is either 8 or 40. But we can see here that 40 is a pretty big number as compared to 8, which suggests that there's more variability. We can get that information right from the range, so that's just kind of one way to look at it. A more typical way to look at it is the variance itself. And the variance is, well, it's the average squared deviation around the mean, but let's talk about what exactly that means and how we calculate variance. So, like I said, what we're interested in with variance is how much things vary from the mean. So let's talk about what that means. So again, let me look at my company A here was 24, 30, 31, 23, 27, right? And the mean, right? So the mean, X bar, is equal to 27. So I want to see how far each of these are away from, let's stop there. So let's look at how we calculate variance. And again, variance is it's a description of how far our data spreads away from the mean, right? And how far that goes. If we have a large variance, right? So a number that is a very large variance indicates lots of spread. Zero variance is what basically a constant, right? Everybody is exactly at the mean. So if we look at this, again, we go back to our data set from company A. We have 24, 30, 31, 23, and 27. And X bar, or the average, was 27. So if we're interested in the spread, we want to know how far each of these numbers is away from the mean, away from this center, right? And so what we do is we actually, we generate what we call difference scores. And we get those by subtracting the mean from each raw score. So 24 minus 27 is minus 3, right? So 24 is 3 below the 27. So this is, again, the difference score. So 24 minus 27 is negative 3. 30 minus 27 is positive 3. 31 minus 27 is positive 4. 23 minus 27 is negative 4. 27 minus 27 is 0. So this is our difference scores and how different each raw value is from the mean, how far they go away from there. Now, in theory, what I would do here is I would just take the average, right? I'd say, well, what's the average of these differences? The problem with that is these negatives and positives, right? And so if I add up negative 3 and 3 and add up 4 and negative 4, I get 0. And in fact, if I just, right, and 0 divided by any number is 0, which would suggest the variance is 0, which obviously the variance is not 0. If I were just to take the raw difference scores, the average, the variance in that case would always be 0. So I can't do that. I have to do something about these negative numbers to capture how far away they are from the mean in absolute terms. So what can I do? Well, I can square them, right? And so then I get these squared difference scores. So the squared difference scores, negative 3 times negative 3 is 9, 3 times 3 is 9, 4 times 4 is 16, negative 4 times negative 4 is 16, 0 times 0 is 0. So see how this got rid of all the negatives, right? Because a negative times a negative is a positive. And this is a way of just arithmetically taking our difference scores and making them all positive is we just square them. Now that we have this, now we can see how far away they are, and we take essentially the average of how far they are from the mean, right? And so we get the average of these squared difference scores. And the way we do that is, of course, like any average, we add things up and then we divide. So we add these, 9 plus 9 plus 16 plus 16. So again, I don't math very well, so I'll come over here to my calculator, and I will say 9 plus 9 plus 16 plus 16 gives me a total of 50. Now, this is referred to as SS, or the sum of squares, right? These are the squared difference scores. The sum of the squared difference scores is SS, sum of squares. And the sum of squares here is 50, right? So 9 plus 9 plus 16 equals 50. Now, you would think if I was just taking the average of these squared difference scores, I would just divide by 5. And because I have 1, 2, 3, 4, 5 pieces of data here. In reality, that's not what I divide by. Just to make things different, the variance is actually the sum of squares divided by the numbers of degrees of freedom. So I don't necessarily want to get too deep into the numbers of degrees of freedom, but for a sample size when we're calculating variance, the number of degrees of freedom is always going to be n minus 1. So in this case, the variance of this sample is 50 divided by 1, 2, 3, 4, 5 minus 1, or 4. So this is going to be 50 divided by 4, which again, go back to my calculator because I don't math well, is going to be 12.5. So the variance, drop my pen, the variance of this sample is 12.5. The mean of this sample is 27. Now, let me take it one step further. Because we don't, although sometimes we use the variance, we don't always use the variance. Sometimes we refer to what's called the standard deviation. And so the standard deviation is just the square root of this, right? So standard deviation is the square root of the variance, right? And so often we will say S is equal to the square root of S squared is how we sometimes see variance. So if you see S squared, you might see V, you might see var is equal to the variance. The square root of 12.5 looks like 3.54. So that is the SD, the standard deviation, or sometimes we just see it as the S of this sample. So our measure of central tendency was the mean, which is 27. Our standard deviation, which tells us the variability of the spread around the mean, is 3.54.